Good evening, welcome to my laboratory. What I'm going to do now is demonstrate that the oscillations in the Ainslie circuit, both Q1 and Q2, have nothing at all to do with the function generator. What you're looking at there is a small power supply. That's another classic from my collection. This is an HP 731A. I'm sure a lot of you out there will probably recognize this little power supply. I'm going to use it instead of the function generator to supply a DC bias current to Tar Baby, which is a replication of the Ainslie NERD circuit, of course. And what we'll be looking at again is the current trace up here. I'm not displaying anything down here. This was where the function generator was, but we're not using the function generator. Its output leads are in storage up here. And I have the power supply output going into the normal place where the function generator hooks up. The red power supply positive output goes to the red function generator connection, and the minus power supply output, the black wire, goes to the negative rail of the circuit, just exactly where the function generator would hook up. Okay, everything else is as normal as in the previous demonstration, and this time I'm also looking at the battery voltage because I guess I forgot to do that. So we got 75.3 volts on the battery before anything happens. Okay, now we've got the Q1 MOSFET and then the 4 Q2s over here, and I'm monitoring the temperature of the Q1 MOSFET, and of course we always monitor the temperature of the load, but that's irrelevant here. All I'm going to do now is show the oscillations and show that they result from a DC bias current. Okay, so right now I've got the thing set up positive, red positive power supply, bias supply to the positive function generator hookup point, and negative to black hookup point. Okay, so now what I'm going to do is just turn up the bias power a little bit and watch what happens. Turning up, turning up, turning up, turning up, turning up. Oh. Okay, so you see that right there? That is the Q1 transistor oscillating. Okay, and I'll prove that to you by unplugging it. Okay, so there I've just unplugged the Q1 transistor. Alright, and there are no oscillations now, and I can even turn the bias current up a little bit more, and absolutely nothing happens because we're the Q1's out of the circuit. Alright, so now let me see if I can plug that Q1 back in. I hope I can. You try this with one hand. Yeah, you know, Ainslie's got 4 people standing around doing things, and I still can't get it right. Alright, now what I'm going to do is I'm going to reverse the polarity of the hookup of that little power supply. Alright, and I'm going to do it by actually reversing the leads here where it plugs in, because this is easier for me to get to. Okay, so easier and quicker just to do it like that. Okay, so now we're looking at what would be the negative part of the signal from your function generator going into the circuit. Alright, so now I'm going to turn up the bias voltage again. Turning up, turning up, turning up, turning up, turning up, turning up, boing. Alright, you see those oscillations there? Right, those oscillations? Those are Q2 oscillations. Alright, and I'll prove that to you by unplugging the Q1 again. Alright, watch. Point. Q1 is unplugged now, just like it was before, and instead of no oscillations, now we have mo oscillations, right? So these are the Q2s oscillating now. Alright, so let me plug the Q1 back in. Just like that. Alright. And you can see that the RF causes the meters to go crazy. You never want to read your meters when you have RF going on. So let me turn that RF down, turn the bias current down. You can see that the Q1 has warmed up. Alright. And I can feel it too, the heat sink's a little bit warm. Okay. So now what I'm going to do is we'll disconnect this power supply. Alright. I can figure out which clip leads it is. We'll disconnect that power supply, and we'll find the function generator output leads, and we'll hook the function generator back up. Negative to the negative bias. And that turned the MOSFETs on for a minute. The AC cycle home. Alright, so now let's get the scope back turned on. Alright, so now remember, sorry, let me readjust the baselines here. Alright, so now remember that's the function generator output. And look at that. Are we really that warm? It is that warm, my goodness. Sucker is warming up. Okay, so anyway, we'll turn this on, and there's your oscillations coming on. Then as I increase, I get Q1 oscillations and go further than that, and they go away, and then I get buku current in the Q1, just exactly like before. All right. And sure enough, we're heating up that Q1 MOSFET. That's real heat. It really feels warm. At 50 degrees C, that's almost too warm to touch there. All right. All right, Q1 oscillations. And going beyond that, lots of Q1 current. Thank you for watching.